Alright guys, so this is your tutorial for calculus assignment number 2, solving, well let's look at the directive here. You want to solve sinusoidal equations. You want to, with no calculator, your directive is to find all solutions and domain restrictions, if any, on the given interval, okay? So we start out with simple sinusoidal equations like sin x equals 0, okay? Well, let me give you a simple one right here to start with. Sin x equals square root of 3 over 2. All you basically need to know is your unit circle, bam, and I only focus on one quadrant of it because that's the first quadrant. The second quadrant goes negative, positive. Third quadrant goes negative, negative. Fourth quadrant goes positive, negative. So all you need to remember is those numbers. So the question you're asked here for this equation, this is an angle. So what angle, when I take the sine ratio of it, gives me square root of 3 over 2 ratio. Okay? So square root of 3 over 2 is part of these points up here, but it occurs in two places, here and here. Well, the sine is equivalent to the y value in the unit circle, so we're looking for what radian is here, because here's where the y value is square root of 3 over 2. So this x, whatever this angle is, that's what x is. It's the angle. All right, well, I know this angle as square root of, pi over 3. This angle right here is pi over 3. That's pi over 2. The whole semicircle is pi. The whole thing around is 2 pi. Okay, so we know one of the answers. One of the answers is pi over 3. Okay, bam. Well, another place where this is going to be the same, square root of 3 over 2, it's going to occur right here as well. Right here, that y value is going to be the same at this point and this point. So if those two y values are the same, well, that's square root of 3 over 2 as well. Remember, if the y values are the same on the unit circle, then you got to include that in your answer. Well, that's not pi over 3. So this, you're adding another pi over 3. So that's 2 pi over 3. And Google a unit circle. Take a look at the radians because it's not quite even. It's not like this pi is split up evenly on the unit circle. It's not. You need to Google it. You need to take a look at it. Okay. So where is the next square root of 3 over 2 going to occur? Well, down here, where this y value is pretty much equivalent to that y value, right? And that y value is pretty much, but those are negative, so I can't use those. All right, so I'm pretty much done, right? No, I'm not, because my interval says I want all the answers from 0 to 3 pi. I'm not to 3 pi yet. All right, I'm only to 2 pi over 3. So if I go around the whole time, okay, that's around 2 pi, which is, 2 pi is 12 pi over, well, in terms of, with a denominator of 3, 2 pi is 6 pi over 3. Okay, 6 pi over 3. So if I add a revolution and I end up in the same spot, that's an answer as well. So I add 6 pi over 3 to a pi over 3, I get 7 pi over 3. And then, see what I'm doing? I added a revolution right here, the plus 2 pi. And then I add it to the next one, and then I get 6 pi over 3 plus 2 pi over 3 is 8 pi over 3. Now, have I exceeded my interval? My interval goes to 3 pi. 8 pi over 3 is, 8 divided by 3 is not 3. So I can go a little bit more, not much. So what can I do? Well, I added 2 pi to get my 7 pi, and I added 2 pi to get my 8 pi. Well, I'm left with adding 2 pi to this one now. Well, if I add 2 pi to that one, I'm going to be way over 3. Okay, so this is my solution set. I don't want to go over 3, and I don't want to go less than 0. So basically, this is my solution set. I can stop right here. All right, I'll be lazy and stop. Okay. All right, so that's your solution set. And if you wanted to write it as a sequence, it would be your starting point, pi over 3, plus 2 pi n, okay? Pi over 3 plus 2 pi n. But that's just the pi over 3 adding. It would also be 2 pi over 3 plus 2 pi n. Okay? So those are your two. And you don't have to write these. No, you don't have to write these. But I at least want you to find these. Okay? So let's do another simple one. Let's do the cosine x equals negative square root of 3 over 2. Okay. So what is the cosine of the angle going to give you? It's going to give you the x value on the unit circle. So let's look for where the x value on the unit circle is square root of 3 over 2. Well, I see where the x value is square root of 3 over 2 here, but it's positive. So I want it negative. Well, that's not negative. That's going to be negative here. Okay? So this value, square root of 3 over 2, comma 1 over 2 is going to be the same here. Okay? So I know that's a solution. I'll put a star there, or an X. And I also know this is a solution. Okay? Because those X values are the same. All right? So what are those? What are these right here? So this little piece right here is pi over 6, right? So this little piece right here is pi over 6, right? So this is a whole pi right here. So that's pi minus pi over 6, which is 5 pi over 6. So one of my solutions, and in your calculator, you would write cosine inverse negative square root of 3 over 2. Cosine inverse negative square root of 3 over 2. And it would give you your solutions. But I just want to write x equals, because I'm not using my calculator. All right, so x equals 5 pi over 6. And what else did I say? This guy as well. So that would be pi over 6 plus 1 pi over 6, which would be 7 pi over 6. And of course, I can add my revolutions. So instead of adding 6 pi over 3, because I had a pi over 3 denominator, now I have a over 6 denominator, so I'm going to add 12 pi over 6. Okay? So I'm going to end up with 17 pi over 6, comma, 19 pi over 6. Now we get an interesting thing right here. 19 pi over 6, based on the interval, let's say if I was doing it like this, based on the interval, 19 pi over 6, that's too much. 19 divided by 6, that's like 3.1 pi or something like that. So that's over. Okay, so I would just mark that guy out, okay, and keep these guys. I was able to add the 2 pi here. I was able to add the 2 pi there. I was not able to add the 2 pi there because it's too much. All right, so there we go. I can just lock those in. And what we're doing is we're solving these, all right? And we're going to find all the solutions to these equations, but also we're going to find out the domain restrictions. Now, sinusoidal equations don't have domain restrictions because most of them are not fractions. But once they become fractions, they have domain restrictions. So let's do another one. Let's say what's the one we don't have? We don't have let's do on this interval right here. Let's use this interval with the not enclosed. So negative 2 pi not included. 2 pi included. So all our answers go from negative 2 pi to 2 pi, but we're not going to include our answer if it's negative 2 pi. So that's basically like greater than that and less than or equal to that. So let's do this one separate. I'm going to make it negative. So sine x equals negative 1/2. All right? Boom. So let's look for where the y value is negative 1/2. So the y value is 1/2 right here. So I know it's going to be negative right here. Okay? And I know the y value would also be 1/2 here and right here. So the solutions I'm looking at are right here. That would be 7 pi over 6. And right here. All right, so that would be 2 pi minus pi over 6. So 11 pi over 6. So those are our two solutions, right? Now that's pretty dang close to 2 pi. Now let's write our interval down. Our interval negative 2 pi to 2 pi. Okay? So we got our solutions that are on the unit circle. How many revolutions can I add to it? Let's see. Well, if I add pi over 2, if I add a revolution to this, 7 pi over 6, I get 19 pi over 6. Now that's supposed to be a bracket right here. My bad, including the 2 pi. Well, that's way over 2 pi. Way over 2 pi, right? So I can't include that, so that's why I X'd it out. But what if I subtract? Here I added a 2 pi, right? Which was 12 pi over 6. What if I minus 12 pi over 6? So let's start with this one. If I minus 12 pi over 6 from 11 pi over 6, that's 11 pi over 6 minus 12 pi over 6, which is negative 1 pi over 6. Okay? So that's subtracting it. Now subtract this one. So 7 pi over 6 minus 12 pi over 6 is comma negative 5 pi over 6. Okay? And then if we keep subtracting here, okay, let's minus this one. All right, subtracting. So that would be negative 13 pi over 6. Well, once again, divide that, you get about negative 2.1 pi. That's outside of the interval, so I've got to basically cross this one out. And if I minus this one, let's see, let me write that. If I minus a 2 pi from this one as well, there's no point. I mean, that's going to be like negative 17 pi over 6. It's way outside of my negative 2 pi range, so I know that's not going to occur. So my final answers are the 7 pi over 6, the 11 pi over 6, the negative 1 pi over 6, and the negative 5 pi over 6. So I'm just going to write that out neat. In order, too, as well. Notice what happens when you put them in order. When you put them in order, you can actually see where you're adding the 12 pi over 6. I'm sorry, my video is a little fuzzy with the... Alright, so I'm adding a 12 pi over 6 there, and I'm also, from negative 1 to 11, is adding 12 pi over 6. So you always are free to add a 2 pi, or in this case, a 12 pi over 6. So that's what I got here for those two. I'll just go ahead and put those in a box. Alright, so we've done the simple ones. Basically, looking at the unit circle, staying within our intervals right here, and adding 12 pi over, or 2 pi, basically. Adding any variation of 2 pi as long as you stay in between these two ranges. Now let's get to the more complex ones. What if we have this right here? Okay? Alright, so what if we have like sine 2x equals 1/2? What do I do there? Same thing. Okay. So, do you remember here when we did sine x equals negative 1/2, and then we just looked at the unit circle and says, well, x must equal that, or x must equal that. You do the same business here. Sine 2x equals 1/2. Excuse me. Sine 2x equals 1/2. So I'm going to write 2x equals whatever I find on the unit circle. Okay? So let's go to the unit circle. So where's the sine 1/2? Sine's 1/2, that's the y value right there. So that's pi over 6. And right there, it's 1/2 right there as well. Okay? Because that's positive, right? That would be 1/2 right there. And so that would be 5 pi over 6. So pi over 6 and 5 pi over 6. And what's our interval right here? Let's keep our interval in mind. Sine 2x. Let's do the same interval as this problem. Sine 2x equals 1/2. Let's use that interval right there. Negative 2 pi to 2 pi. Okay, so 2x equals 5 pi over 6. And that's out of order. Sorry. Pi over 6, 5 pi over 6. Okay? So let's do the same thing we just did. Okay, we're going to add that 2 pi, which is 12 pi over 6. Again, so pi over 6 becomes 13 pi over 6. Okay, and then 5 pi over 6 goes to 17 pi over 6. Now you say, well, Coach, aren't we over the 2 pi? Not necessarily. 17 pi over 6 is bigger than 2 pi, yes, but look, you haven't divided by 2 yet. You haven't divided by 2 yet. So I'm going to divide this out, which is the same as multiplying everything by 1/2, right? See this 1/2? That's going in. It's going in. It's going to turn all those 6's into 12's. Sorry, not pi over 6, pi over 12. Okay, now we have a new pattern emerging, and really what we see happening now with our pattern, we're adding pi. Okay, we're adding pi. And there's the pattern right here. We're adding pi. Now what do you say? Well, you say, how is that adding pi? Well, it's going from pi over 12 to 13 pi over 12. That's plus 12 pi over 12. And it's adding from 5 pi over 12 to 17 pi over 12 is adding 12 pi over 12. So you have a new pattern emerging here, okay? Now what's 17 pi divided by 12? Well, that's not more than 2 pi. It's going to be 1 point something. So I can even take this a little bit further and add another 12 pi over 12. So 13 pi over 12. And then I will get, well, look, I'll get 25 pi over 12. Well, 25 pi over 12, that's more than 2 pi. So I can mark that out. And I can stop. But I'm not taking into consideration the negative, so I need to go in the negative direction as well. Well, how do I do that? Well, I mean, it's totally up to you. I could just make room for the negatives. Pi over 12 right here, 5 pi over 12, 13 pi over 12, 17 pi over 12. And then I'm going to see I've got those. And now I'm just going to work backwards. So minus 12 pi over 12. All right, so 5 pi over 12 minus pi. If I can add pi, I can minus pi, right? And so that's going to be negative 7 pi over 12 minus pi, and that's going to be negative 11 pi over 12. And then I can minus pi again. That's going to be negative 15 pi over 12. Okay, and I think I'm getting to the point, I don't know. Let's try one more. Minus that, that's going to give me negative 23 pi over 12. Now, negative 23 pi over 12 isn't quite negative 2 pi. Okay, so I'm getting away with getting really, really close. So there, I'm really close to negative 2 pi. I know that I'm not going to be able to minus another pi. Okay, so there it is. Negative 23 pi over 12, negative 15 pi over 12, negative 11 pi over 12, negative 7 pi over 12, pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay, And those are your solutions for that one. Okay? All right, so these are fairly challenging as far as writing goes, but as far as actual mathematics, these are simpler than trig identities, I assure you. Okay, so the next one. So let's talk some domain restrictions. You got the tangent x equals 1 from negative 2 pi to 2 pi, not including the negative 2 pi. So if you get a negative 2 pi answer, disregard it. Okay, where does the tangent x equal 1? Okay, well, let's try and see where, let's see, let's do another one. Let's do, let's see. Well, I did one. One's kind of the only easy one. I'll do a simpler one. Well, one's really the only simple one. So I guess we can actually do that together. All right, we can actually do that together. So tangent x equals 1. All right, because we don't get too heavy in trig and calculus, but let's go ahead. And where is the tangent x equal to 1? Is tangent x is equal to y over x on the unit circle. Okay, the tangent of theta, I'll call this theta, the angle, is equal to y over the angle. So you ask yourself, where is y over the angle equal to 1? Well, y over x equal to 1. It's pretty simple. We all know that y over x is equal to 1, where the y and the x's are the same. Square root of 2 over 2 and square root of 2 over 2, which is pi over 4. Okay? So basically, x is equal to pi over 4. Okay? Right there. And we know that's where y over x equals 1. And we also know that, well, this is where it's equal to negative 1, but, sorry, 1 as well, but it's negative 1. Here, you have a negative divided by a negative, all right? So that's where it's equal to positive 1 as well. So that's pi over 4, and that's 5 pi over 4. Yes, 5 pi over 4. All right, so pi over 4, comma, 5 pi over 4. And if you notice what we just did on the unit circle, if you remember from trig, all right, we just basically traveled in a semicircle, right? If you travel in a semicircle, you know, what's going around in a full circle? Well, it's just going to be another semicircle. So now, going from here to here, back to here, back to here, back to here, back to here with the rotations, we're basically only adding pi. Okay, so just add pi. So pi over 4, well, you don't have to add pi there because you get 5 pi over 4. Just add pi and you'll end up with every subsequent answer. 5 pi over 4, and pi is 4 pi over 4. So you get 9 pi over 4, 13 pi over 4. Okay, have we passed the mark yet? Well, let's take a look. If we're doing the problem in the same interval that you see on your paper here, which we are, negative 2, let's see, tangent 1, negative 2 pi to 2 pi. So at this point, we've actually 9 pi over 4. Yeah, we've actually passed our mark here with 9 pi over 4. So we can mark that out and mark that out, okay? Now, we can write it, we give ourselves some room to work backwards now for the negative solutions. All right, so we can minus 4 pi over 4. That will give us negative 3 pi over 4. And then minus 4 pi over 4 again, that will give us negative 7 pi over 4. There you go. And those are your 4 solutions for the tangent. Now, solutions in which it is undefined, all right, or domain restrictions, that's where the denominator of all these equals 0. And I'm sorry, I know this is taking a real long time. But where's the denominator? There's only a denominator where, in a couple places, right here and right here. Okay? So, basically, tangent is sine over cosine, right? So you basically have to figure out where's the cosine equal to 0. Where is the cosine equal to 0 for number 6? on this interval negative 2 pi to 2 pi, right? Not including this negative 2 pi. So it's kind of this negative 2 pi. It's kind of tough right here. And you have to figure out, all right, where is this cosine squared x equal to 0 from this interval, including negative 3 pi to 3 pi. So that's up to you. All right, guys. And basically, I'm going to basically give you some tips and pointers on this. When you have extra stuff on the outside, you need to go ahead and get rid of it before you look on the unit circle. All right, so this stuff needs to be get rid of. You got to divide by 2 and multiply by 2 right here. Okay, this stuff right here, the squared, you've got to square root both sides first. Okay, square root both sides first. And then you're going to have a positive and negative 1. You're going to have to solve both of those. Okay, and I know this is run long, but good luck, guys. Peace.